How does glow-in-the-dark work? Have you ever wondered how glow-in-the-dark objects work? Whether it's toys, stickers, or clothing, these materials emit a soft, eerie glow even after the lights are turned off. The secret behind this fascinating effect lies in a scientific process called phosphorescence, a type of luminescence where materials absorb and slowly release light energy over time. Unlike materials that glow due to heat, such as a filament in a light bulb, glow-in-the-dark objects shine without producing heat, making them a unique example of stored light energy. Phosphorescent materials contain special compounds known as phosphors, such as zinc sulfide and strontium aluminate. These materials have the ability to absorb light, especially ultraviolet, UV, or blue light, and store the energy at an atomic level. When light energy excites the electrons in the phosphors, they move to a higher energy state. However, instead of releasing this energy immediately, as fluorescent materials do, phosphorescent materials have a delayed release mechanism. The electrons slowly return to their normal state, gradually emitting the stored energy as visible light over an extended period. This is why glow-in-the-dark objects continue to shine even after the initial light source is removed. The intensity and duration of the glow depend on several factors. The type of phosphor plays a crucial role. Strontium aluminate is a more advanced material that glows brighter and lasts longer than traditional zinc sulfide. The amount and duration of light exposure also matter. The more light the material absorbs, the longer it will glow. Additionally, UV light, such as sunlight or black light, is the most effective at charging phosphorescent materials. Temperature can also influence the glow, as higher temperatures may speed up energy release, causing the glow to fade faster. Glow-in-the-dark technology is widely used in everyday life. It is commonly found in children's toys, wall stickers, and novelty items, but it also serves more practical purposes. Safety signs, emergency exit markers, and watch dials often use phosphorescent materials to ensure visibility in the dark. In specialized fields, glow-in-the-dark technology is used in biomedical imaging, scientific research, and even military applications. For those interested in experimenting with this phenomenon, making your own glow-in-the-dark object is possible. By mixing phosphorescent powder, such as strontium aluminate, with a clear binder-like resin or paint, you can create glowing designs that charge under light and emit a beautiful afterglow. In conclusion, glow-in-the-dark materials demonstrate the incredible interplay of physics and chemistry, allowing objects to store and gradually release light energy. The next time you see a glowing object in the dark, you'll know that it's the result of phosphors absorbing and slowly emitting light, creating a mesmerizing and useful effect.